here's another example of solving a right triangle in a coordinate plane. Okay, so this one says the coordinates of the vertices of triangle RST are -3, 5, 4, 5, and 4, -2. And we're supposed to find the side lengths to the nearest hundredth and the angle measures to the nearest degree. Okay, so same idea as last time, but hopefully it helps you guys to get another example of this, right? So let's look again. So again, here's our given information. We have basically the vertices of this triangle in the coordinate plane, right? And we want to know a couple things, right? We want to know the side lengths to the nearest hundredth, okay? And we want to know the angle measures to the nearest degree. All right, so maybe I'll make my triangle in red this time. So my R is -3 and 5, so 3 to the left and 5 up, which should be right here. Okay, I then have S, which is 4 and 5, so 4 to the right and 5 up, which is right here. Okay, and then I have T, which is 4, -2, so I'll go 4 to the right, 2 down. Okay, so here's my triangle. Okay, now that my triangle is kind of built, I like to put my vertices now. So again, this is R, right? This is going to be S, and this is T. Okay, and I'll very carefully try to make straight lines here. I don't want to take too much time and find the straight line tool. Hopefully I'll make a mistake, but you know, if I do, whatever. All right, so in the last one here, let's try to go as straight as possible all the way up here. Okay, great. Now, the first thing we can probably say here when we're talking about the angle measures is we can probably say that angle S, or the measure of angle S, is going to be equal to 90 degrees because we'll say because RS and ST, or segment RS is perpendicular to segment RT, or ST, excuse me, okay? By, I'll just write definition of perpendicular, right? We know that vertical lines and horizontal lines form 90-degree angles, right? And so I can just maybe go ahead and mark that. We know that we're dealing with a right triangle here because of that, okay? The next thing we could maybe do is talk about the side lengths. Again, they're very nice to us in these examples, and they gave us, lines that, like a y equals line, right? The lines that have all the same y value, and another line that has all the same x value. So I can just kind of count here, right? So like 1, 2, 3, 4, 5, 6, 7 here, right? So that's 7 spaces. So I'm going to say that RS is 7, right? And that's important. I'll put a box around that. That's part of my answer. Okay, and that ST is 1, 2, 3, 4, 5, 6, 7. Okay, and so ST here again is 7. Well, it looks like we have an isosceles right triangle here. Okay, and maybe I should stop the problem right now and just be able to say that we should be able to solve everything and not do any more work. Okay, unfortunately, I don't think we're all there. Hopefully some of you are. Maybe pause the video and finish it and see if you're right. But we'll go ahead and can continue to solve this maybe the way that we were doing before. Okay. Now I know these are both 7, right? So maybe I can look at the rest of this problem maybe through the context of, let's say, angle T, right? So I'll look at angle T and ask myself, well, which sides do I actually know here? With regards to angle T? Well, I know the adjacent leg, right, and I know the opposite leg, okay? Well, that's tangent that we're talking about, right? And so what I can do now is say that the tangent of T is going to be equal to opposite over adjacent, so that's going to be 7 over 7, okay? And since I know what that ratio is, I can actually find the measure of angle T by saying that the measure of angle T is going to be equal to the inverse tangent of 7 over 7, or the inverse tangent of 1, right? And so I now find that my measure of angle T equals, and you can go over to your calculator here and take, 7 divided by 7 gives you 1, right? And now I can type the inverse tangent of that, and that gives me 45 degrees, okay? So the measure of angle T equals exactly 45 degrees, okay? Well, again, we know those pretty fancy, the pretty fancy way to find that last angle R is just going to be, knowing that the acute angles of a right triangle are supplementary, right? So I can take 90 degrees and subtract the measure of angle T, and that should be equal to the measure of angle R. right? And so the measure of angle T here is obviously 45, so long story short, we get the measure of angle R is also 45 degrees, okay? And so at this point, we've now found all three angle measures, right? We know that that one's 90, we have 45 and 45, right? So we have a right isosceles triangle, which is a 45, 45, 90 triangle, right? So 45 degrees, this one's 45 degrees, okay? And again, if you guys remembered your special right triangle ratios, you know it's 1, 1, radical 2, right? So I should be able to say, without even finishing the problem, that RT is 7 rad 2, okay? But let's, you know, for those of us that aren't quite there, maybe don't quite remember, let's just go ahead and plug this into the distance formula, okay? So I'm going to rewrite this, the coordinates of R and T just because I don't want to lose track here. So R is -3. Maybe I'll erase this a little bit more here. So R again is -3 and 5, right? And T here is 4 and -2. Okay, and I'm just going to plug this into the distance formula, right? So I'm just going to say that y2 minus y1, or in other words, -2 minus 5 squared, plus, I'm now going to do x2 minus x1, so that's 4 minus a -3 squared. Okay, and if I start simplifying this down, I'll find that I've got -7 squared plus, this is going to be now 4 plus 3 is 7 squared. Okay, this is now going to give me, it looks like 49 plus 49. Okay, I know that 49 plus 49 is going to give me 98. Okay, now I'm looking for a perfect square factor of 98. Okay, so I'll continue to think about, all right, what number multiplied by itself is going to be a factor of 98? And what I end up finding here is that radical 49 times radical 2 is the same thing here. And I know that, rad 49 is the same thing as 7, so I get 7 radical 2, which is what I said before. But that is going to be RT, okay? So there's lots of ways that we can do this, right? There's lots of knowledge that we're bringing together. But I think it's sort of fun when that happens, okay? So I hope the extra example was helpful. Remember, there's lots of different ways that we can solve right triangles.